student, welcome back. Today we are going to continue exercise 1.3 number system from class 9 SF syllabus. And the fourth question as follows. Express 0.999 which is a never ending number in the form of P by Q. Let's start. Let us take x equal to 0.9999 which is a never ending decimal number. This decimal expansion is non-terminating repeating decimal. Let us consider this one as 1 and let us multiply x with 10. Why 10? Because you can see that after decimal point there exists a single digit which repeat again and again. So if we multiply 10 with this number, we get 9.9999 and again it is also a never ending number. Let us consider it as 2. Now let us subtract 1 from 2. So what we get? We get 10x equals to 9.9999. Subtract x equals to 0.9999 from the above. If we subtract, we will get this side 9x and this side, what do you get? You will only get 9 because after the decimal point, this never ending part in both the cases will be removed. So, what is x? X is 9 by 9. That means we can write it as 1. But wait, we are asked to write the answer in P by Q form. Can we write 1 as P by Q form? Why not? We know that every number is divisible by 1. So we can write 1 as 1 by 1. We can write 1 as 1 by 1. So this is the required answer of question number 4. Go to the next interesting question. That is question number 5. Question number 5 says that what can be the maximum number of digits be in the repeating block of digits in the decimal expansion of what? Of 1 by 17. And after that there is a tag question that perform the division to check your answer. So let us go for the first part. As we are asked to divide 1 by 17, so required answer will be the number of maximum digits in repeating block of digits is 17 minus 1, that is 16. This is the required answer. Now we are asked to perform the division to check the answer. Let us do that. 1 by 17. So let me write here 1 and we are dividing it by 17. First of all, let us take a decimal point. Why? Because 1 is less than 17. So if we take a decimal point, we can keep on taking zeros wherever we need. So we need a 0 first here. But still 10 is less than 17. So here we have to take one more 0 after the decimal point. So we will get a 0 here. Now we have 100 and 17 is less than 100. And 17 5s are 85. Let us subtract 85 from 100. We get 15. 15 is less than 17. We can take one 0 due to this decimal point. And then let us multiply 17 by 8. We get 136. Let us again subtract 136 from 150. We get 4 from this side and 1 here. Again 14 is less than 17. So we can bring one more 0. Now 140 is very close to 136. Again 17 8s are 136. Let us again subtract. Then we will get here 4. 4 is less than 17. So let us take a 0. Every time we are borrowing 0 from this decimal point. Now we get 40. So 17 2s are 34. We get 6 again. Again 6 is less than 17. So let us take one more 0. Now 60 and 60 is greater than 51. So 17 3s are 51. If we subtract, we get 9. Let us take a 0 from the decimal point. Then, now here it is 90. 17 5s are, we know that it is 85. So, if we subtract, we get 5 here. Okay? Let us continue the division from this side to this side. Now, 5 is the remainder. Due to this decimal point, we can take a 0. Then 50 we are getting. Let us take 17 into 2. 17 2s are 34. So, what we are going to get? We are going to get 6 in this side and 1 from this side. 16 is less than 17. Let us take a 0. Then 17 9s are 153. So from here we get 7 as reminder. Then let us take one more 0. So 70 we get. Now 4s are 68. So if we subtract it from this side, we will get 2. And then it is 20. 17 1s are 17. We get 3. Then let us take one more 0. Due to this decimal point, we can take. Now again 17 1s are 17. So if we subtract now, we get 3 and then 1. 13. 13 is less than 17. So let us take a 0. 113. 17 7s are 119. 119. If we subtract 119 from 130, so we will get this side 1 and also this side also 1. 11 is the remainder. Let us take one more 0. So now we can multiply 6 with 17. Then we get 102. Okay. So last part we will do in this side. 10 minus 102 means 8. Let us take a 0 from this decimal point. 80. So 17 4s are 68. And then we will get here 2 and here 1. We get 12 after subtracting 68 from 80. Again, due to this decimal point, we can take a 0. We have to take because 12 is less than 17. Now we have 120. So if we take 17, 7 again, we get 119. Now what is going to happen now? You see, 120 and 119, if we subtract, we get 1. Okay, so you see this side of the board, we have started from 1, started dividing 17 by 1, and finally we get back 1 as reminder. Now if we restart the division method after 1, taking 1 as dividend and again long division, so we'll see that all these numbers will again repeat after this 7. So this is the last point, and again from the beginning, from the 0 to 7, again it will repeat. That means total number of or maximum number of digits in the repeating block of the digits are here only. These are those digits. So let us check how many digits are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. Yes, we get 16. So this is success. So we can say that yes, it is verified by division method that if we divide 1 by 17, we get what? 16 digits. Those 16 digits, the series of the digits again repeat again and again. This is the required answer. This is the most interesting question in entire chapter, you could say. So let us discuss the most interesting question. Particular question, you can say that look at the several examples of rational numbers in the form of what? In the form of P by Q, where Q is not equals to 0 and P and Q are integers with no common factor other than 1 and having terminating decimal or terminating decimal expansion. Can you guess what property Q must satisfy? Let us check. In the question, first it is said that look at the several examples of what? Rational numbers. Rational numbers. Rational numbers can be divided into two types of decimals. What are they? Number one is terminating and number two is non-terminating, repeating decimals. Now, whether terminating or non-terminating repeating decimal, both types of decimal follow certain common rule. Number one, we can represent these types of decimals in P by Q form, where P and Q are integers. Number two, Q cannot be equal to 0. Number three is P and Q are co-prime. Co-prime means when two integers only have one particular factor between them. When two numbers having one common factor in between the numbers, and that common factor none other than 1. Now, every terminating and every non-terminating repeating decimals follows these three rules. Let us go to the question now. in the question it is said that a number which are following these three rules and terminating decimals also. That means we don't need non-terminating part here. Now we are asked to check what particular rule in the form of P by Q follows, or which rule or which particular property Q is satisfying so that a number becomes terminating decimal. Let us check. Let us discuss with certain examples. Let us take first example as 0.3. So this terminating decimal, it is a terminating decimal because after 3 there exists nothing. So we can write 3 by, at in the denominator we can write down 1. Why 1? Due to this decimal point we have to take 1, and after decimal how many digits exist? We can say there exists only one digit. To that reason we have to take 0. It is 1 0. So 10. That means if we divide 3 by 10 we get 0.3. Let us go to the next example. Number 2. Let us take it as 4.15. Okay. So in this case you can see that 4 is an integer. Why it is integer? Because this is the whole part of the number, and after that the fractional part is written in terms of decimal. So we will write here 415, and obviously following the same rule, due to this decimal we have to take 1, and after decimal how many digits are there? We can say there are 2 digits. So due to this 2 digits we have to take 2 zeros. Okay. Now next is, or you could say the last example, let us take third example as 2.051. Okay. Again in this case 2 is a integer. Why? Because 2 is a whole number. Whole means not broken part, and then the broken part or the fractional part actually written here in terms of decimals. So let us write down. The number will become now 2051. Due to this decimal point we have to take 1, and after decimal how many digits are there? 1, 2 and 3. So we have to take 3 zeros. Now you see the board very carefully. Can we write this one as 3, 10 to the power 1, this fraction as 415 by 10 to the power 2, and in this case 2051 by 10 to the power 3? Yes, we can write, because this is the 10 one time, so it is only 10 into 10 twice. If we multiply 10, so it is 10 square. If we multiply 10 3 times, so thrice, it becomes 10 cube. Now what is the common thing in these three numbers? 10, 10 square, 10 cube. The common thing is that all the numbers are multiple of 10. They are multiple of 10. Multiple of 10. Now, how can we break 10? We can break 10 as 2 into 5. We are splitting 10 in its prime factors, 2 and 5. How many 2's are there? There are 1 2 and 1 5. We can write 10 to the power 1 as 2 to the power 1 into 5 to the power 1. 10 to the power 2 as 2 to the power 2 into 5 to the power 2. 10 to the power 3 as 2 to the power 3 into 5 to the power 3. It means that these three numbers are following a special pattern. What is that pattern? The pattern is 2 to the power n into 5 to the power m. So, by discussing all these things, or after discussion these, so we can say now that if we divide a number, any number, by the multiples of 10, by the multiples of 10, or by 2 to the power n into 5 to the power m, then the number becomes terminating decimal. Okay, that means if Q is in the form of 2 to the power n into 5 to the power m, then we can say that the decimal become terminating decimal. We can say it like this, that P by Q is a number where Q is following the rule 2 to the power n into 5 to the power m, then the number becomes terminating decimal number. This is the rule that Q is following here. Let us discuss question number 7. Question number 7 says that write three numbers whose decimal expansion is non-terminating and non-recurring. Well, first of all, let us discuss what are irrational numbers or non-terminating, non-recurring number, because irrational number is actually non-terminating, non-recurring number. Non-terminating means the decimal part of a number never ends. It keep on going. And non-recurring means the digits in decimal part never follow a same pattern. It keeps on going, but the numbers are randomly coming. Okay? So, for example, number 1, 3.1428593271059 and you can keep on writing. This is not a pi, but it is an irrational number or non-terminating and non-recurring number. Number 2, we can write 4.1231123 and it keeps on going like this. In this case also, no doubt in the decimal place we have 3 digits only, but you can see that the digits are not following the same pattern. Every single time one is increasing. So it is also a non-terminating, non-recurring decimal or non-terminating, non-repeating decimal, or in the simple language, irrational number. The third and last one is, let us take 7.282882888 like this. It will go, it will keep on going. Now, in this case also, you can see that expansion not following any pattern. So, this is the answer of question number 7.